Hello students. So students, we all know that chemical reactions takes place in three ways, that is losing, gaining, sharing. Losing and gaining associated in the same bonding and sharing is a completely different. So students, answer, all these reactions takes place for what reason? In order to achieve noble gas configuration. Yes or no? The stable noble gas configuration. So how do they can get? Some elements lose electrons, some elements gains electrons, some elements shares electrons. How can you identify which elements loses, which elements gains and which elements shares? Depends upon the electronic configuration of that element. Yes or no? That decides the valency of that element. What is the valency? Whether the element should lose or gain or share. That depends upon the electronic configuration of the element. So based on this types of bondings, types of the way the electrons are participating in the bonding, we have the types of chemical bonds. First type is called as electrovalent bond or ionic bond. Very simple. Electrovalent bond or ionic bond. Look at the name ionic, meaning ions. The bond between the ions. That's it. That is ionic bonding. Yes, sir, students. So the bond between the ions means which ions? Is it between the same ions? Do same ions combine? Do positive combine? No. Do negative combine? No, they repel with each other. Then which ions combine? Positive always combines with a negative. Why? Why? Because positive shows electrostatic attraction towards a negative. That attraction is called as ionic bonding. Got the clarity, students? So in which case we can expect this bonding? What are the examples? Everything we'll discuss. First of all, by definition, the electrostatic force of attraction, the strong not weak. This is not like normal weak force of attractions, intermolecular, not like that, not general van der Waals forces. This is the strong intermolecular electrostatic force of attraction between the oppositely charged ions is called as ionic bonding. Oppositely charged ions means between cations and anions. The chemical bond between two atoms due to the transfer of electrons from one atom to the another atom is called as ionic bonding. Yes or no? How cations formation takes place, students? When an atom loses electron. How anionic formation takes place? When another atom gains electron. Why this atom is losing and why that atom is gaining? Ultimately to achieve stability. What's the meaning of stability? Noble gas configuration, either duplet or octet. Got the clarity? So here what is ionic bonding? The bond means what? The strong electrostatic force of attractions between oppositely charged ions is called as electrovalent bond or ionic bond. Let's see some of the examples. So first of all here, electrovalent bond is not possible between similar atoms. Yes or no? So can we expect this bond, this strong attraction between positive between metals? No. Between non-metal? No. Between a metal and non-metal every time, remember. Almost between a metal atom and a non-metal atom. Of course, hydrogen ion also possible. Hydrogen is a non-metal, but in general, I am saying. So this type of bonding requires two atoms of different nature. One atom should have the tendency to lose electrons and other atom should have the tendency to gain electrons. So this losing electron property is called as electropositive in nature. This gaining electron property is called as electronegative nature. That means in the combining elements, one element should be highly electropositive and other should be highly electronegative. What's the meaning of this? One should have a capacity to lose, other should have a capacity to gain. Then only they will form ionic. Yes or no? Sir, if they don't have a capacity, how do they will bond? That is the next bonding, by sharing. So here focus on ionic only. For the formation of ionic bonds, what are the conditions? One should be electropositive, opposite should be electronegative. Answer in periodic table in general, which elements have this electropositive character? Metals. Which elements have this electronegative character? Non-metals. So the ionic bonding is mostly expected between a metal and a non-metal. Sodium chloride, magnesium chloride, sodium bromide, all this. Right. That is electronegative nature. This is a note. Next, examples. Students, look at the examples. We have sodium chloride example. Let us consider the atomic level. First, sodium atom. So what is the atomic number of sodium? 11. What is the configuration? 2, 8, 1. You already know that only valence electrons participate in the bonding in order to achieve noble gas configuration. Yes or no? So how many electrons are there in the valence shell? Only one electron, right? Now what is the condition? What is the criteria for sodium? It needs to gain 7 electrons or it can lose 1 electron. Which is the best? Losing 1. So it loses, you can see this electron was lost. Next, look at chlorine configuration. 2, 8, 7. Listen carefully. Chlorine contains 7 electrons in its valence shell. For chlorine, according to the chlorine's criteria, according to its configuration, for chlorine, which is the best option? Losing 7 or gaining 1? Gaining 1. So the electron of sodium is completely moved out of sodium atom and it is gained by the chlorine, students. It is gained by the chlorine atom. After this formation, now the sodium becomes sodium ion, yes or no? Na plus ion, and chlorine becomes, look, you can see the star, chloride ion, Cl minus ion. Why? Because sodium lost an electron, chlorine gains an electron. Now look at their configurations. What is the valence shell in sodium ion? 8. Second shell, 8 electrons, yes or no? What is the valence shell here? Third shell, 8 electrons. Both 8 and 8. Octet configuration or not? Now here is the crucial point. Sodium ion achieved noble gas configuration stability. Chloride ion achieves noble gas configuration stability. So do they exist independently in the nature, sodium ion and chloride ion? The answer is absolutely no. Are they completely unreactive now? The answer is no. Still they are reactive. Why? Why? Because, students, they are stable, correct, according to the configuration, but they are not neutral. What is the point? They are not neutral. Sir, why? They have a charge. They have a positive charge and negative charge. So these charges are the reason why these ions again reacts and they form a neutralized compound. So why they are losing or gaining electrons? For the stability. In the process of getting stability, they are getting the charges also, yes or no? They are losing this neutrality. Now what is the next step? They want to get neutralized. So the chemical bond formation involves two processes. One is stability, second one is neutrality also. Sir, but noble gases, yes, noble gases, they already have 8 electrons, they are stable, they are also neutral, right, students? They are also neutral. They have equal number of protons and electrons. But these ions, do they have equal number of protons and electrons? They got stability. But are they neutral? No. That's why they are combining. Which ions are combining? Positive will become neutral. +1 equal to 0? No. -1 equal to 0? No. When it will be equal to 0? +1 -1 equal to 0. Understood? So this sodium ion combines with chloride ion in what ratio? 1:1 ratio. 1 Na plus 1 Cl minus. +1 -1 equal to 0. Then how to write the formula? NaCl. Are we representing any charge on this molecule? No charge. Why? It is already neutral molecule and it is already stable molecule. When did it get its stability? Sodium lost 1 electron, chlorine gains electron. Stability. When do they get the neutrality? This sodium ion combines with chloride ion, then they get neutral. This attraction between sodium ion and chloride ion, between these opposite ions, this attraction is called as ionic bonding. Got the clarity, students? What is ionic bonding? The electrostatic force of attraction between a cation and an anion is called as ionic bonding. This attraction, that's why they're chemically combining. Ultimately, for what reasons? In order to get the stability and in order to get the neutrality also. So this ionic bonding is expected between which type of elements in the periodic table, students? Between electropositive element and electronegative element. What is the nature of electropositive element? It shows tendency to lose electrons. What is the nature of electronegative element? It shows the tendency to gain electrons, yes or no? So losing electron cation, gaining electron anion. Between cation and anion, the attraction, that is ionic bonding. So let's see what are the favorable conditions for the formation of these ionic bonding. So do all the elements means? No, there are exceptions also. Do all metal, when metal and non-metal combine, every time can we expect ionic means? No, not every time. There are many exceptions are there. For example, lithium can form covalent compounds. Beryllium can form covalent compounds. Magnesium also can form covalent. Aluminium. So exceptions are there. Why the exceptions? These are the factors. A metal atom should have, look at these are the conditions for ionic bond formation. These are the conditions for electropositive elements. That means elements which have capacity to lose, which have a tendency to lose. For them, what are the conditions they should qualify in order to lose electrons? First, less ionization potential. What is IP? We discussed in the periodic table chapter, yes or no? The minimum amount of energy required to remove the electron from the valence shell of an isolated neutral gaseous atom. That is called as IP. So the combining electropositive element should have less IP or more IP? Less IP. What is the meaning of less IP? That means with minimum amount of energy only, the element should be capable to lose electron. More IP means what? It need more energy to remove that electron. Yes or no? Less IP means with small energy also, that means it can easily lose electron. What is the meaning of less IP? The element, the metallic element can easily lose electron. You already know top to bottom IP values decreases, atomic size is increasing. Yes or no? So that's why lithium forms covalent compounds. So if IP is less energy is required to remove the electron, hence electrons if IP is less energy is required to remove the electrons, hence the electrons can be lost easily by the donor atom. So less is the IP value, easily lost electron. If it is easily losing electrons, it forms a positive ion. More size. If the size is more, then the nuclear pull on the outer electrons is less, therefore electrons can be lost easily. Just now I have said, atomic size top to bottom increasing. If atomic size is increasing, does the valence electrons get that much of nuclear attraction? No. We can easily lose. Yes or no? Of course, both are directly related. More is the size, less is the IP. Understood? These are the two factors where favorable conditions for the formation of a cation, right? Less cation charge means the charge on the cation should be less. A cation with more charge is difficult to form. For example, the formation of Ca+2 occurs in 2 steps. Less charge means, for example, first group elements. How do they get the stability? By losing 1 electron. Second group elements by losing 2 electrons. 13th group elements by losing 3 electrons. Now, which are more metallic? Which are more electropositive? Which can form easily cation? First group elements. Why? With 1 step only they can get stable element. As students, by losing 1 electron only, they can easily attain stability of getting octet configuration. Look at calcium here. Calcium, first step it loses 1 electron. Second step it loses another electron to become Ca+2. Here 2 steps are there. But for first group elements, only 1 step. Understood? So what does it mean? Less cation charge is a more chance for formation of cations. That doesn't mean second group elements do not form cations. They form cations, but easy way of formation of cations, what we are discussing here, the conditions. So with single electron can easily lost, right? Instead of losing 2 electrons. Got the clarity? Right. These are the factors. Next, features for the acceptor atoms. That means these are the conditions. Previous conditions are for cationic formations, and these are the conditions for anionic formations. You already know all are opposite. Yes or no? First, look at the first condition, high electron affinity and electronegativity. What is electron affinity? The energy change when an electron is added this time to a neutral isolated gaseous atom. What is electronegativity? The tendency of an element to attract the electrons from the sharing pair, right? That is electronegativity. So these acceptor atoms, that means these anionic elements, for example, non-metals, when do they have more nature in order to gain electrons? When do they show more tendency to gain electrons? When they have high electron affinity. That means if they can easily gain that electron, easily form anion. Yes or no, students, right? So the tendency, more energy is released when an electron is gained by it. So resuming in greater stability of the acceptor atom. So more, if an element can show more tendency in order to gain electrons, more is energy released. About energy also we discussed in the previous video. Yes or no? If it releasing more energy, getting more stability. Yes or no? That's why. So less size. Therefore, cationic formation, more size is the favorable condition. For anionic formation, less is the size. Why? If small is the atomic size, this time anions are the losing or gaining. The incoming electron, does it experiences more nuclear force or less nuclear force? More nuclear force. Why? Because valence shell is closer to the nucleus. Yes or no? If the valence shell is closer to the nucleus, the incoming electrons experiences more nuclear force. More nuclear force means what? It can easily get into that atom, into the valence shell. Understood? So here for anionic formation, less size is the favorable condition. When the size of the atom is small, then the nuclear pull on the electrons is more. Therefore, electrons can be gained easily. Less anion charge, same. Gaining 3 electrons or gaining 2 electrons, gaining 1 electron. Which process is easy for anionic formation? Gaining 1 electron. Yes or no? Oxygen need to gain 2 electrons. Nitrogen need to gain 3 electrons, but fluorine only 1 electron. So which is easy for the anionic formation, which is favorable? Gaining 1 electron. Same like cationic condition also. Which is easy? Losing 1 electron. So the extreme metals are first group elements. Extreme non-metals are 17th group elements. Their valence is 1. First group elements, they can easily attain noble gas configuration by losing one electron, and they can 17th group elements can easily attain noble gas configuration by gaining one electron. Got the clarity? So the bond formation between first group and 17th group is highly ionic nature, mostly between cesium and fluorine. Cesium is the highly electropositive element, fluorine is the highly electronegative element. So the extra negative charge, the same point, more difficult to form. So based on these properties, first group and 7th group gets along well with each other, formation of strong ionic bond formations. Look at the examples: sodium chloride, potassium fluoride, lithium fluoride, etc. are strong ionic compounds. Why they are strong? Why? Because these highly reactive metals are like electropositive in nature. They form high cations. Highly electronegative elements, they are highly anionic in nature, and the attractions, opposite attractions are also very strong. Yes or no? That's why they can form strong anionic strong ionic compounds. So properties of ionic compounds, the general properties, we are not talking about sodium ion and chloride ion, we are talking about sodium chloride, ionic compounds together. So physical state means, are these ionic compounds available in the nature like solids, liquids or gases? All these ionic compounds available in the nature as solids. They are hard solids, not general solids. Sodium chloride, is it solid or liquid or gas? Solid only, yes or no? They are solids, but as well as they are hard solids, as well as they are brittle in nature also. That means easily breakable. So what is this contradiction? We are saying they are hard, and how it can be brittle also at the same time? I'll explain. They are hard because, students, all these ions are guided by the strong inter-ionic attractions, that is electrostatic force of attraction. That's why they are very strong. But all these ions are arranged in a crystal lattice, the layers of crystals. So between the layer and layer, if the terminal ions all are positive ions and the terminal ions of other layer is also positive, what happens? Repel. Yes sir, if they repel, can easily break. This crystal is very hard, but layers of crystals are easily brittle in nature. Why? Because if the same ions are the terminal ions, positive or negative, then what will happen? Repulsions will be more. Yes or no? That's why they are brittle in nature, as well as a crystal lattice. In the crystal lattice, they are very hard substances. So due to the strong force of attractions between the oppositely charged ions, which keeps them in their allotted positions, in a particular positions, all surrounded by opposite ions. So the brittleness of the crystals is due to the movement of their layers of crystals on the other layer by application of external force. By the application of external force, if the layers are arranged in such a way, if positive and positive are face to each other, then they will repel and be easily brittle in nature. Next, melting and boiling points. So what are melting and boiling points? The temperature at which a solid changes into liquid is melting. A temperature at which a liquid changes into vapor is called as boiling. Yes or no? So I already have told you, these are guided by strong force of attractions. In this melting and boiling, are we breaking the bonds? No, we are not breaking the bonds. We are just breaking the inter-ionic attractions. Still attractions are there, just we are weakening them, that's it. So there are already the attractions are very strong. Yes or no? Is it easy to weak these attractions by limited energy? Do you think they can easily convert into liquid? The answer is no. These ionic compounds have very strong, very high melting and boiling points. For example, boiling point of water is 100 degrees Celsius. Water is not an ionic compound, covalent compound. Do you know the melting point of sodium chloride? It is more than 1000 Kelvin. Not boiling, melting point only, that much high. For not that is an example only. In general, all ionic compounds have high melting and boiling points. Why? Why? Because strong attractions. In order to break those attractions, not so easy. Next, we need to provide more energy. Solubility. What is solubility, students? What is the solubility? The ability in order to dissolve, in order to attract towards the opposite ion, that is solubility. Sir, ionic compounds are soluble in polar solvents like water. Why? Because water is made up of polarity. It has a polarity, right? Partial positive charge of hydrogens, partial negative charge on oxygen. So these ionic compounds are mostly soluble in water. Why? Because ionic compounds are made up of positive cation, negative anion. They attracted towards the partial positive and negative charges of water. So easily soluble in water. That's the solubility. Like dissolves in like. So electrical conductivity. Ionic solids consist of oppositely charged ions held together. Hence conductivity is not possible. Remember, sodium chloride in the solid state do not conduct electricity. That solid state means only pure sodium chloride do not conduct. Sir, it contains opposite ions, right? It contains opposite ions. Ions are the reason for the carriers of electricity. But are they moving? No, that's why. When they conduct? When this sodium chloride, when add in water, now that solution will conduct electricity. Why? Why? Because the moment when you add sodium chloride into the water, what happens? The free ions will be released. Yes or no? It's not. It's no more like perfectly arranged in a crystal lattice. They attract with each other. Opposite ions attract with each other. So these ions freely move in the solutions, and these free movement of ions are the reason for the conduction of electricity. So electrical conductivity, one of the main points, students. Solid ionic compounds do not. In the aqueous solution, yes. Not only in aqueous solution, in the molten state also, yes. Or fused state. Molten means what? Converting a solid into liquid at high temperatures. Yes, sir. Just we discussed about melting point. So in molten state, that means liquefied sodium chloride, and in aqueous solution, that means the solution of sodium chloride in water conduct electricity. But solid, no. Why? No free movement of ions. That is what? Electrical conductivity. Ionic compounds are good conductors of electricity due to the presence of mobile ions. Mobile ions means free movement of ions. Next, highly reactivity. These ionic compounds are highly reactive, students. Why? Because they are made up of positive charges and negative charges. When there is a opposite ion, they can show that attraction, yes or no, so fastly. For covalent compound, we need to break that bond. Again, we need to, it's a time taking. But ionic compounds are undergo reactions very fastly, very quickly. Have you seen the precipitate reactions, color change reactions? So these exchange reactions, double displacement reactions very quickly. So ionic reactions are very fast. Ionic compounds reactions instantaneously in a fused or aqueous solution. Again, here also, in mostly fused means molten state, or in aqueous solution form, the reactions occurs instantaneous, means like in a point of time. They can, in a point of second, second of time, they will happen. Formation of ions, rapid union of these ions in the solution form new compounds easily. Directional properties. A given ion in the ionic compound crystal is surrounded by a uniform electric field around it. So what are these directional properties and non-directional properties? Means, students, listen. Directional means like sodium chloride. I will take one example. Sodium chloride is made up of sodium ion, chloride ion. Now answer. Where is the bond? Show the bond in ionic compound which is sodium chloride. Is it possible? Can you show? Some students are thinking like this. Sir, here is the bond. Where? Here it is a positive charge. Yes or no? Does this sodium ion, does it showing this positive charge only in one direction? No. Charge will be shown throughout all the directions. Yes or no? All the directions. So, and one more thing. In the crystal lattice, one sodium ion is not bonded with one chloride. One sodium ion is surrounded by many chlorides, 6 chlorides in general. Why? Because, sir, how then the formula can be NaCl6? No. That chloride also not giving complete negative charge to 1. It is giving 1/6 of its negative charge. Okay, that's a completely in-depth concept. So, in general, the point of directional nature is that charge, that bond is not giving in a particular direction. It is giving the charge. Yes or no, students? The charge will be shown throughout. So opposite ions will be surrounded. Again those chloride ions again surrounded by sodium. Again those sodium chloride. That's how the crystal lattice is. Understood? But in the case of covalent compounds, which is our next bonding, water molecule. This is water molecule. Here you can show the bond. Yes or no? You can say there is a bond between hydrogen, oxygen. There is a bond between oxygen, hydrogen. Yes or no? But is it possible? Can you show that bond in ionic compounds? That's why ionic compounds in general we don't represent any bond. Are we writing sodium chloride like this, students? Are we writing NaCl by this bond representation like this? Na bond Cl? No, we are not showing. So that is non-directional nature. The bonds in ionic compounds are non-directional. Understood? That means they do not give the bonding only in one direction. They are the charged particles. They show the charge throughout surrounding. Understood? That's how they are arranged in crystal lattice, students. That is what the directional property meaning. So next, isomorphism. Crystals of different ionic compounds having similar arrangement of ions. I already have told you how all these ions are arranged like a single molecule. No, all these ions are arranged by opposite ions. Again, they are arranged by opposite ions. So that similar arrangement of ions as well as the geometry are known as isomorphs. That means they have the same shape and same arrangement. That type of compounds with similar sizes, similar arrangement of ions and similar shapes, they are called as isomorphs, and the phenomenon is called as isomorphism. Examples are also given: zinc sulfate .7H2, water of crystallization, and FeSO4.7H2O. These two are the examples which exhibit this phenomenon called as isomorphism. They have same arrangement of ions in the crystal lattice as well as same shape. The valency of these isomorphs also same, Zn plus 2, Fe plus 2. Understood? So that's what about ionic compound, students.